You ever just stop and look up at a skyscraper, a bridge, or even the hospital down the street and just wonder how it all came together? They're incredible, right? Monuments to what we can build. But behind every single one of them is a hidden world of mind boggling complexity. And honestly, a world that's been pretty inefficient for a long, long time. Today, we're going to pull back the curtain on the digital revolution that is completely changing how we build our world right from the ground up.
All right, let's kick things off with a number that should really make you think. 37%. Global research shows that our built environment, our buildings and all the construction that goes with them, is responsible for about 37% of all global energy-related CO2 emissions. That is a huge footprint, which also means it's a huge opportunity to do things better.
So, why has the industry struggled with this stuff? Well, for decades, it's pretty much operated in these isolated bubbles or silos. You've got all these brilliant people, architects, engineers, contractors, but they've all been working off their own separate drawings, passing info back and forth in this endless chain of emails and phone calls. It's been a totally disconnected blueprint.
And you can probably guess what happens when things are that disconnected, right? Critical information just falls through the cracks. Changes don't get communicated to everyone. This all leads to miscommunication, clashes on the actual job site that mean expensive, wasteful rework, and just a huge amount of squandered materials. This is the very problem that a whole new way of thinking was designed to fix.
And that solution is building information modeling, or as everyone calls it, BIM. It's a total, fundamental shift in how we approach designing and building things. And let me tell you, it is so much more than just making a pretty 3D model. This iceberg analogy is perfect. A lot of people hear BIM and they immediately think of a piece of software, like Revit. But that's just the part you can see, the tip of the iceberg. The real power, the real magic of BIM is everything happening underneath the surface. The collaborative process, the shared pool of information, and the standards that finally get everyone on the same page.
The easiest way to really get it is to just break down the name letter by letter. The B is for building. And that can be anything, a bridge, a house, an entire airport. The I is the real secret sauce, information. This is all the data that makes the model intelligent. Things like what a material is made of, how much it costs, how it performs. And M is for modeling, which is the process that ties the building and all that rich information together in one single shared space.
Okay, here's a perfect way to see how different this is from the old way, from CAD. In a traditional CAD drawing, a wall is just a bunch of lines. The computer has no idea it's a wall, so if you move it, you have to go and manually update every single plan, every section, every drawing where that wall appears. But in BIM, that wall is an intelligent object. It knows it's a wall. It has data attached to it. So if you move it, every single view and schedule in the entire project updates. Instantly, automatically. This really gets to the core philosophy of BIM. You essentially build the entire project twice. First, you build it virtually inside a computer where you can find all the problems, solve clashes between different systems, and fine-tune every little detail. Then, and only then, do you go and build it physically out on the site. This one idea saves an unbelievable amount of time, money, and materials. But here's where it gets even cooler. BIM doesn't just stop at 3D. The real game changer is when you start adding new dimensions of data, and each one gives the model a brand new superpower. First up, you've got 4D BIM. This adds the dimension of time. So by linking your 3D model to the construction schedule, you can literally watch a time lapse of the entire building coming together step by step. This lets teams perfect the construction sequence, plan out logistics, and spot potential delays long before a single worker ever steps foot on the site. Next, there's 60 BIM, and this one is all about sustainability. This dimension embeds energy analysis data right into the model, so designers can simulate how the building is going to perform. They can test out different materials, move windows around, try different types of insulation, all to create a super energy-efficient building before they've even broken ground. And the results? Well, they really speak for themselves. Just look at this chart. This compares the energy use of a building designed the old way versus one that was optimized with 60 BIM. The drop in energy needed for heating, cooling, and lighting isn't small, it's dramatic. This is how we actually start to make a dent in that 37% number we saw at the beginning. And finally, there's 7D BIM, which is all about looking at the building's entire life. This packs the model with every piece of information you'd need for operations and maintenance. We're talking everything from the warranty info on an air conditioning unit to the exact paint color on a specific wall. This creates what's called a digital twin of the real building, and it's a complete game changer for managing it long term. So this all sounds amazing in theory, but what does it actually look like out in the real world? Let's take a look at a real project that put this whole data-driven idea to the test. This is a building called The Edge in Amsterdam, and it's one of the most sustainable office buildings on the planet. The results they got by using BIM are just staggering. Energy use slashed by over 65%. Material waste, which is usually around 15 to 20% on a job like this, was cut down to just 4.6%. And rework, fixing mistakes from on-site clashes, that was reduced by a massive 87%, which is basically zero. These are the kinds of numbers that prove building it virtually first really, really works. And why is that long-term 7D thinking so incredibly important? Well, get this. The cost to actually run a building for 30 years can be as much as 4 times what it cost to build it in the first place. So, by using BIM to design for easier operations and maintenance right from day one, the savings over the building's lifetime are just immense. So really, what you're seeing here is how BIM acts as the central nervous system for a whole project. It's the hub that connects everything: collaboration, time, cost, analysis, and links it all directly to better decision-making and, ultimately, a successful project. Now, is it a perfect, seamless transition for the industry? Of course not. There are real hurdles, like the upfront cost and getting different software programs to talk to each other. But the future that BIM makes possible is just way too exciting to ignore. We're really moving from the idea of static models to creating truly living buildings. And that next step is the living digital twin. Just imagine, the BIM model is now connected to the actual physical building through a whole network of sensors, the Internet of Things, or IoT. These sensors are feeding real-time data on temperature, on how many people are in a room, on how equipment is performing, right back to the digital model. Then AI can analyze all that data and constantly fine-tune the building's performance, making it smarter and more efficient every single day. And that really brings us to the big picture. BIM isn't just about making one building a little bit better. It's a tool that has the potential to make our entire built world more sustainable, more efficient, and more responsive to our needs. So I'll just leave you with this question. If every single new building had an intelligent digital twin, one that was constantly learning and optimizing itself, how could we fundamentally reshape our cities for the better?